Welcome to Museum Weekend. My name is Stephanie. I am the curator at Gateway Science Museum, and today I'll be leading you through a bunch of fun activities, a tour of the museum, and some of our neat things we have. So come in and join us on the tour. Let's join Daphne, one of our curiosity guides, as she shows off our lending library kits.
Hi, this is Daphne from the Lending Library. Make sure to check out a kit on our website. You can pick it out from 12 to 5 on Fridays. So I'm going to show you one of our newest kits. It will be ready for the public soon, and it's a volcano kit. So I'm going to show you how it works. So you're going to get some material. You need some vinegar, food coloring, baking soda, and soap. And it has this little tube where you can put all the ingredients. So first, you're going to read the instructions. Add 2 spoonfuls of baking soda. And about a spoonful of dish soap. Okay, so we're gonna mix it. And you wanna add some food coloring. You can do whatever color you want. I'm gonna do red and yellow. Mix it, and then you're gonna add some vinegar. And let's wait for the reaction to happen.
I think I hear Kurt in the Valley Gallery. Let's go see what he's up to.
Hi, I'm Kurt, and today we're going to talk about 2 of my favorite things in the entire museum. This is our short-faced bear. Arctodus simus is the scientific name. This is one of the largest bears that ever lived, standing over 11 feet on its hind legs. If we look up there, the short-faced bear is called the short-faced bear for a reason. So he has a very short nose, but a gigantic nasal cavity that goes way far back in his brain, so we know they had a really good sense of smell. We think that is how they found their food. The next thing we're going to talk about is this wonderful skeleton of Smilodon fatalis, otherwise known as the saber-toothed cats. This is one of the iconic animals from what we call the Ice Age. You might be familiar with Ice Age movies. Well, Diego was a saber-toothed cat. The first thing anyone would notice is the large canine teeth. Those are the largest teeth of any cat that's ever lived. Smilodon fossils are very common in California, and these cats came from La Brea tar pits. And so anyway, I want to thank you for taking a quick look at our giant fossils that greet our visitors when they come to the Gateway. Thank you.
Hi everyone, I'm Michelle Ott, and I'm the artist in residence here at the Gateway Science Museum. One of the things that I get to do in my role here is to incorporate art into the science programming that we already have going on. One example of that is this mural that we incorporated into the welcome experience in the entryway to the museum. So on one side we have our paleo garden, and on the other side we have, reflecting back, this mural painted by several Chico State student artists. So we've been able to incorporate not only student artists, but also visitors to the museum to start to see the natural history through time and space in this painted mural. The mural is open and available all the time for you to come and visit. So we hope that you'll be able to come to the museum, visit the garden, and see the mural outside sometime in the future soon. See you here.
Let's join Leilani for another activity.
Hi, my name is Leilani and I'm a field trip tour guide at Gateway Science Museum. And today I'm going to teach you about circuits and how electricity is used to turn on a light bulb and all your other favorite electronics. Have you ever wondered how the light in a light bulb turns on? Well, in order for that to happen, you need a circuit. But what's a circuit? A circuit is a continuous flow of electricity. You need this for any sort of power to turn on. Where do we get the power? Well, the power needs to come from a power source. A very common example is a battery. So if we have a battery and we wanted to connect it to, say, a light bulb, how do you think we can get the power from this battery to this light bulb? We can use wires. Wires have a metal wire that runs through the inside of this plastic covering to protect you. And then there's metal clamps on both sides here. Next, you want to connect the wire from the battery to the light bulb. And since you want a complete circle, you want to make sure that you complete the rest of the circuit by connecting another wire from the other side of the light bulb to the other side of the battery. It's really important to notice that here we have a complete circle and it goes in all one direction. If you notice, if you take off one side, the light bulb turns off. But if you connect it again, the light turns on. Now we have a light bulb.
Let's go see what Laura's doing in the garden.
Hi everyone, welcome to Gateway Gardens. It's a great day to be out in the garden this weekend because there's so many things happening out here. We have this beautiful manzanita bush that is in full bloom and there's new growth coming up everywhere. We have wildflower seeds popping up into sprouts like crazy in our foothills exhibit, and I'm really excited to show some of it to you all. So this is a European honeybee visiting some of the urn-shaped flowers of this manzanita plant in our garden. The manzanita is one of the first plants to bloom in the garden in the springtime, and it'll actually start to show its first flowers in January. But as you can see, it's in full bloom now. Manzanita bushes are also exciting because they form these galls that are on the ends of the leaves. These galls are induced by little aphids, and they prompt the plant to start producing excess leaf tissue that forms a little house that the aphids live inside and lay their eggs until they come out and grow. It doesn't hurt the plant at all, and it's really interesting to look at with those bright red colors on the edges of the leaves. Over in our foothills garden, there are teeny tiny wildflower sprouts popping up all over the place. There's other new growth popping up all over the garden. This Oregon grape is about to start blooming too. Oregon grapes are really fun. You can always tell when you're looking at an Oregon grape by digging just below the surface, and if the roots are orange, you can tell that's what it is. Now let's do an activity with some of the plants that we can find right here in Gateway Gardens. So we're going to do an activity today from our Garden Detective series, and this is the Leaf and Flower Prints activity. We can use stuff from right here in the garden and materials that I had at home to finish this activity. So we're going to need a rubber mallet, a sheet of wax paper, some sheets of just plain paper, or you can use fabric for this, some kind of material to work on that you don't mind hitting with a hammer. I picked out a coloring book from home, and then some plant material. Herbaceous plants work best for this. Herbaceous means that they are not woody, so they're juicy on the inside as opposed to kind of like a stick. So what we're going to do for this activity is layer everything on top of our coloring book or other material. So we're going to put the sheets of paper on top and then arrange the plant material however you want it to look when your print is finished. This is a great way to play with the plants that you have in the garden and the pigments that they produce, which is what makes their color. When plants are blooming, it's really fun to use flowers because you get all kinds of colors from those pigments in the petals. Then we're going to lay the wax paper on top of that plant material and get our rubber mallet, and as we hit the plants underneath the wax paper, it's going to allow the pigments to bleed out of those plant cells and produce the prints that we're looking for on the paper or fabric or whatever other material. Hard because you don't want to crush the cells into the paper. You just want to allow them to bleed. And then once you think you've done enough, you can peel that wax paper off and take off the plant material. And what you'll be left with, they don't always work out 100%, so it's fun to experiment. But what we're left with is the pigments of the plants that we were playing with. So you can kind of see the shapes and preserve the leaves and some of the colors that were inside those cells. Here's an example of the same activity that I did over the summer when there were more flowers blooming in the garden. You can see how the pink pigments from some of the red flowers came through onto the fabric in this case.
I think I see coal.
Hello, my name is Cole, and I run the Gateway Science Museum's public outreach effort, the Science Cart. You can probably find us at the Farmers Market or college campus soon. So let's open this up. So this beautiful artwork was done by Michelle Ott, our resident museum artist.
Hi everyone, it's Michelle again. This time I'm here at the Science Cart. To create this moire pattern on the Science Cart, what I've done is I've taken different colored paints and painted lines and then made alternate patterns with overlapping lines. The effect of it is so interesting to me, and I think it's really beautiful because it creates this vibrating effect in your eyes. But you can see moire patterns in screens, sometimes fabrics, you can see them. And we wanted to do it here just to give this Science Cart a really exciting feeling so that people are sort of drawn to it. Thanks for checking out the Science Cart. Back to you, Cole.
So here we can see our 4 skulls that we're going to talk about today. So first we have the eastern cottontail rabbit. And this is what is known as an herbivore. An herbivore only eats plants. So the herbivore is never really going to have to bite anything, right? So it's going to want to be able to grind things in the back of its teeth. So we can see these molars back here. They're meant for grinding back and forth. You can almost imagine this little stick back there or something, right? With the carnivore, so this is used for biting and chunking and chewing. So we can see that, and if you look and compare the molars back here, they're less significant in the overall scheme of its mouth. Now, this one is interesting, because with the carnivore, remember these big, gigantic teeth? They're what we know as canines and dogs, and we also have them, our big chewing teeth. With these, they're big too, so you'd automatically assume that it's a carnivore, right? But surprisingly, that's not it. So, remember when we looked back at our herbivore earlier, it had these little grinding teeth. This back here has massive grinding teeth the size of its skull. That is actually used for chewing wood. This is the skull of a beaver. So this is a really unique example of an herbivore because it's not exactly what you think. So the last thing we're going to look at is actually omnivore. Now, an omnivore is something that eats both plants and animals. So it kind of eats whatever it wants, right? Now this has really, really different teeth because it doesn't even have teeth. So this is a snapping turtle. And what's interesting about it is they don't have teeth. And that's because they actually have beaks. And what they do here is that they snap. That's why it's called a snapping turtle, right? It's almost like a pair of scissors cutting, right? So all of these exemplify very different things. Some are herbivores, some are carnivores, and some are omnivores. And those are the three different types of consumption within the animal kingdom. Well, thank you very much for your time. I hope you guys enjoy the other exhibits laid out today.
Thanks for joining us for part 1 of our Butte County Museum Weekend. The next part is a live talk with our paleontologist. Join us through the link in the description.